Hello and welcome to Pre-Algebra Lesson 2. And in this video, we're going to be learning about expanded notation. So our lesson objectives for today would be to learn how to write a number in expanded notation. And we also want to learn the difference between standard and expanded notation. So in our first lesson, we learned all about place value. I taught you how to use this place value chart to find the place value for all the digits in a given number. Now, when we think about expanded notation, all we're simply doing is we're writing a number in a way that it emphasizes the place value for each digit in that number. So this is kind of just a continuation of the last lesson. And in fact, in the first lesson, I gave you a couple of examples where we wrote a number in expanded notation. Now, let's say I took a number like 1035, and we want to write this in expanded notation. Well, the first thing is we need the place value for each digit in the number. So let's feed this into the place value chart. So we start with the rightmost digit, and we put it in the rightmost column of the place value chart. So the 5 goes into the ones place. And as we move left on the place value chart. So the 3 goes in the tens place, the 0 goes in the hundreds place, and the 1 goes in the thousands place. So now that we know the place value for each digit in the number, we can write the number in expanded notation. All we need to do is form the sum of each digit multiplied by its corresponding place value. So starting with this 1 on the left, it's in the thousands place. So each digit, that 1, multiplied by its corresponding place value. If it's in the thousands place, we multiply it by 1,000. Then plus. Next we have a 0 in the hundreds place. Now that 0, as I've previously explained to you, is just a placeholder. But to illustrate expanded notation, I'm going to go ahead and include it for now, although you don't have to. So the 0 here is multiplied by 100. Then plus, we have a 3 in the tens place. So that digit 3 is multiplied by 10. And lastly, we have a 5 in the ones place. So we'll have plus 5. That's the digit times 1, the place value. Okay, let's do a little multiplication now. So 1 times 1,000 is 1,000. Plus 0 times 100 is 0. Plus 3 times 10 is 30. And then plus 5 times 1, that's 5. So let's just write this as 1,000 plus 30 plus 5, right? We don't need to include that 0. So essentially, when we write a number in expanded notation, you can see that it's emphasizing the place value of each digit. This 1 has a value of 1,000. This 3 has a value of 30. This 5 is still a 5. The reason this is still a 5 is because it's in the ones place. 5 times 1 is just 5. The reason this is a 30 is because it's in the tens place. 3 times 10 is 30. And the reason this 1 is 1,000 is because it's in the thousands place. 1 times 1,000 is 1,000. So it's a pretty simple concept overall. And remember, when we talk about this 0 here, it's a placeholder, right? It's a placeholder. We don't have any hundreds in this case, right? We don't have any hundreds in this case. But our number system will allow us to write 1035 with this 0 saying, hey, I don't have anything there, but hold that space. Otherwise, what would you have? This 1 would collapse down and you wouldn't be able to tell the difference between 135 and 1035. So you get all kinds of problems. So let's take a look at another one. Let's say we want to write the number 22,359 in expanded notation. Well, let's get the place value first. So I'm just going to feed this into the place value chart. The 9 goes in the ones place. The 5 goes in the tens place. The 3 goes in the hundreds place. The 2 goes in the thousands place. And then this 2 here is going to go in the 10,000s place. So to write the number in expanded notation, again, we form the sum of each digit multiplied by its corresponding place value. So there's a 2 for the digit times its corresponding place value. It's in the 10,000s place. So just 2 times 10,000. Plus, now we have a 2 in the thousands place, so 2 times 1,000. Plus, now we have a 3 in the hundreds place, so 3 times 100. Plus, we have a 5 in the tens place, so 5 times 10. And then lastly, plus, we have a 9 in the ones place, so 9 times 1. Let's do some multiplication. 2 times 10,000 is 20,000. Plus 2 times 1,000 is 2,000. Plus 3 times 100 is 300. Plus 5 times 10 is 50. And then plus 9 times 1, that's 9. So again, by writing this number in expanded notation, we can see the true value of each digit in the number. This 2 has a value of 20,000. This 2, let me do it in a different color because they're both 2's and are side by side. This 2 has a value of 2,000, right? It's in the thousands place. This 3 has a value of 300. This 5 has a value of 50. And then this 9 has a value of just 9. So each digit gets its value, again, based on where it is in the number, and that's why we call it a place value system. Let's look at another one. Okay, let's say we had 759,275. So let's feed this into the place value chart. So the 5 goes in the ones place, the 7 goes in the tens place, the 2 goes in the hundreds place, the 9 goes in the thousands place, the 5 goes in the 10,000s place, and the 7 goes in the 100,000s place. So to write this in expanded notation, again, we form the sum of each digit multiplied by its corresponding place value. So this digit is a 7. Its place value is the 100,000s place, so 7 times 100,000. 7 times 100,000. Then plus. Next, we have a 5 in the 10,000s place. So 5 times 10,000. Then plus, we have a 9 in the thousands place. So 9 times 1,000. Then plus, we have a 2 in the hundreds place. So 2 times 100. Then plus, we have a 7 in the tens place. So 7 times 10. Then lastly, we have plus 5 times 1. Right? We have a 5 in the ones place. 5 times 1. So we do a little multiplication. 7 times 100,000 is 700,000. Plus 5 times 10,000, that's 50,000. Plus 9 times 1,000, that's 9,000. Plus 2 times 100, that's 200. Plus 7 times 10, that's 70. And then lastly, plus 5 times 1, that's 5. So by taking this number from standard notation and putting it in expanded notation, we can see the true value of each digit in the number. The 7 is 700,000, right? Because it's in the 100,000s place. The 5 is 50,000 because it's in the 10,000s place. 5 groups of 10,000, 50,000. The 9 is 9,000, right? It's in the thousands place. The 2 is 200, it's in the hundreds place. The 7 is 70, it's in the tens place. And lastly, the 5 is still a 5 because it's in the ones place. Let's look at another one. All right, for the next one, let's write 36,255,927 in expanded notation. Now, some of you might be going, well, where's the place value chart? At some point, you have to be able to do this without a place value chart. You have to simply memorize the place values. So if that's something you can't do yet, pull out a place value chart, write this number into the place value chart so that you can get the place value for each digit in the number, and then continue with me. But otherwise, remember that there's a trick you can use. And in case you didn't watch the first video where we talked about place value, I'll explain it for you. So the rightmost place you should be able to remember is the ones place. As you move to the left, you're just multiplying by 10. So in other words, if you think about this as just 1. As I move left, I multiply by 10. This would be 10, right? It's the tens place. It's the tens place. Then as I move left, again, I multiply by 10. This just keeps going forever and ever and ever. You just keep multiplying by 10. So 10 times 10 is 100. So this is the hundreds place. Okay, then this would be the thousands. And let me make that apostrophe a little better. And then this would be the 10,000s. And this would be the 100,000s. This would be the millions. and this would be the 10 millions. And again, the way you figure this out is the rightmost column is always the ones place. So you just think about it as just a 1. As you move to the left, you multiply by 10. So 1 times 10 is 10. So this is the tens place. Now I have a 10. Multiply by 10 again, you get to 100. So now this is the hundreds place. Multiply by 10 again, you get to 1,000. That's the thousands. Then 10,000, then 100,000, then a million, then 10 million, so on and so forth. That continues forever and ever and ever. So you could have a number as large as you want, and provided you had enough time, you could sit there and write out the place values for each digit in that number. Now, let's take this number and write it in expanded notation. So it's kind of a big number, so it's going to take a little time. We have a 3 that's in the 10 millions place, so we would have 3 times 10 million. Then plus, we have a 6 in the millions place, so 6 times 1 million. And plus, we have a 2 in the 100,000s place, so 2 times 100,000. And plus, we have a 5 in the 10,000s place, so 5 times 10,000. And plus, we have another 5, and that's in the thousands place, so 5 times 1,000. And plus, we have a 9 in the hundreds place, so 9 times 100. And plus, we have a 2 in the tens place, so 2 times 10. And lastly, we have plus 7 times 1, right? We have a 7 in the ones place. So we do a little multiplication. 3 times 10 million is 30 million. 30 million. And again, that's telling me that the value of this 3 here is 30 million. Then plus, we have 6 times 1 million, which is 6 million. 6 million. So the value for this 6 is 6 million. Then plus, we have 2 times 100,000, or 200,000. The 2 is worth what? 200,000. Then next we have 5 times 10,000, so plus 50,000. 50,000. So this 5 is 50,000. Then plus, we have 5 times 1,000, which is 5,000, so 5,000. So this 5 is a 5,000. And then we have plus 9 times 100, or 900. So this 9 is worth 900. And then plus, we have a 2 in the tens place, so 2 times 10, or 20. So this 2 is a 20. And then lastly, we just have plus 7, right? 7 times 1 is 7. This is just a 7. So your number, 36,255,927, written in expanded notation, looks like this. 30 million plus 6 million plus 200,000 plus 50,000 plus 5,000 plus 900 plus 20 plus 7. So again, just breaking it down and showing you the true value of each digit in that number. Okay, for the last example, let's look at one that's really big. So we have 10 billion, 5,327,005. Now the good thing about this number is I included a lot of zeros. And when you have zeros and you write a number in expanded notation, you can skip them. So in other words, I'll have this 1 here. This is in the 10 billions place. Because essentially this is the ones, the tens, the hundreds. This is the thousands, the 10,000s, the 100,000s. This is the millions, the 10 millions, the 100 millions. Then this is the billions and the 10 billions. Okay? So this 1 is in the 10 billions place. So I'd have 1 times 10 billion. Then plus. Now all these zeros are basically just placeholders. So when we write the number in expanded notation, we don't have to put them. So I can kind of just skip down to the next non-zero number. So that's a 5, and that's going to be in the millions place. So 5 times 1 million. Then plus. Next I have a 3 in the 100,000s place. So 3 times 100,000. And plus, I have a 2 in the 10,000s place, so 2 times 10,000. Then plus, I have a 7 in the thousands place, so 7 times 1,000. Then plus, I have a 5 in the ones place, so 5 times 1. Let's do a little bit of multiplication here. 1 times 10 billion is just 10 billion. Okay, then we have plus 5 times 1 million is 5 million. Then plus 3 times 100,000 is 300,000. And plus 2 times 10,000, that's 20,000. And plus 7 times 1,000 is 7,000. And plus 5 times 1, which is 5. So again, all we're doing is we're breaking the number down to see the value for each digit in this number. So this 1 is a 10 billion. This 5 is a 5 million. This 3 is a 300,000. This 2 is a 20,000. This 7 is a 7,000. And then lastly, the 5 is just a 5 because, again, it's in the ones place. 5 times 1 is just 5.